All right, picking up where we left off at number 25, we have 2 points plotted on a grid. It says which equation best represents the line that passes through the 2 points. So multiple ways of doing this. I'm going to stick with doing our linear regression trick since it says which line. So we have a point at -2, 6 and 1, -4. If I'm unsure if those are correct, I can see on the graph here the 2 green dots are in the right spots. I could even zoom in so I have a 1. There we go. So we have 1. So I can get rid of the minor grid lines. Now it looks more like that one. Okay, so we can create our equation, and it should perfectly match one of these. So y1 is approximately mx1 plus b. We get that m is -3 1/3 and b is -2/3. Again, if we're not sure what those numbers are, we can type m and b and then convert them to fractions using the toggle right here. So we have m is -10/3, b is -2/3, so d is going to be our answer. Of course, as usual, we want to be solving that using the 2 points, plugging them into point-slope form, and then converting point-slope form into slope-intercept form. We have a table. It says which exponential function models this situation. It doesn't say whether this is a regression. I don't believe it is because it doesn't say which one best models it, but we can still use regression to solve it anyways. So if we do 0, 1, 2, we don't even need all the points if it's not regression. We just need 2 points for exponential or linear, or 3 for quadratic. We can do y1 is approximately ab to the x1. And we get a is 9 and b is 0.9. So since this is measured in thousands, a is 9,000 and b is 9. So a is 9,000, b is 0.9, so that gives us g. In reality, we should be finding our y-intercept using the 0, 9,000 to eliminate h and j. And then we do 8,100 divided by 9,000 to find what we're multiplying by from step to step is 0.9. So that's the proper way, but regression can give us the answer as well. Number 27, what is the positive solution? So we have to know that a solution is an x-intercept, and then we can go graph it. -22. So our positive solution is 2. So we have 2, 0. Our negative solution would be -11. So we would just put 2 as our answer in a text box or whatever format it is on the current star. To solve that properly, we should solve it by factoring. So we'd have x plus 11 times x minus 2. Then our solutions would be -11 and +2. That one arguably might even be faster by graphing than by factoring, but it's close. A university will spend at most $4,500 to buy monitors and keyboards for a computer lab. Each monitor will cost $250. Each keyboard will cost $50. Which inequality represents possible combinations of x, the number of monitors, y, the number of keyboards that it can buy for the computer lab? So this one, Desmos, since it's an inequality, isn't really going to help us. We need to just match up words with these inequalities. So it says at most 4,500. Meaning we have less than or equal to 4,500. That eliminates f and h. So we're left with g and j, and it says that the monitors are 250, and down here it says x is the number of monitors. So we need to pair those up and put 250x and 50y. So that would leave us with g as our only possible answer. Construction manager is monitoring progress of the build of a new house. The scatter plot and table show the number of months since the start of the build and the percentage of the house still left to build. A linear function can be used to model this relationship. Which function best models the data? So we have linear and best models, meaning we're doing a linear regression. So we're going to put 0, 1, 2, 3, 4, 5... and then 100, 86, 65, 59, 41, 34. Linear regression, y1 is approximately mx1 plus b. So our best estimate is -13.5x plus 97.8. So that would be A. Given f of x equals x squared minus 36, which statement is true? The only 0, 6, can be found when 0 equals x minus 6 times x minus 6. That would create a perfect square trinomial, x squared minus 12x plus 36. That's not correct. The only 0, 18, can be found when that. Nope. The zeros negative 6 and 6 can be found with a difference of squares factoring. That's the correct answer. And then negative 18 and 18 can be found that way. So let's just check how we can use Desmos to verify what we already know is the right answer. X squared minus 36, if we do x minus 6 times x minus 6, as the first one says, that does not match that. If we do x minus 18 times x minus 18, that's way over here. Definitely doesn't match. X minus 18, x plus 18. Now it's at least symmetric. And then finally, our correct answer, x minus 6 and x plus 6, gives us the exact correct answer. So that one is C, or H. A function is shown. I guess, yeah. F of x equals 7 minus 4x. What is the value of f of negative 5? This is what we call a simplified explicit equation, meaning we can plug in x values to evaluate the function. So we can put negative 5 here. That's 7 plus 20 is 27. Now, let's actually talk about evaluating functions. We can define f of x equals 7 minus 4x, exactly like they have. Then we can evaluate functions using Desmos. So now that I've called that f of x, I can literally type in f of negative 5, and it just tells me the answer is 27. Like, there's nothing fancy. Like, I'm typing in exactly what it says in the prompt, and it's giving me the exact answer. Which graph best represents this? Well, we can graph that. So it's already in function form or function notation. So we have x plus 3 minus 2. So this one is going to be, which graph best represents y equals negative 4 times x plus 3 minus 2. So let's zoom in a bit. It looks like our x-intercept should be between negative 2 and negative 3, and it should be downward sloping. So j is already the only one. And then our y-intercept should be below 7. It looks like it's at negative 14. So it looks like j is going to be our correct graph for that. We would... trying to think what we would do by hand to best solve that. I would probably, since negative 14 is off the graph, I would probably just find 2 points that I know are on the graph. So maybe evaluate the function at negative 3 and positive 2 by plugging those in for x, and then match up which one does the right thing. That one's actually easier to solve using Desmos, I think. A rare case. Which expression is a factor of that? So to know what a factor is means it divides evenly into that polynomial. So I'm going to make a division and put 10x squared minus 19x plus 6. And then to know if it divides evenly, we need to come up with a straight line. So if this is a linear factor, then the other linear factor is a straight line as well. So 10x minus 3. You'll notice that it's not a line. In fact, there's a line that passes diagonally between these two green things, and that line is an asymptote rather than a factor. So let's try 10x minus 1. That one also has a slant asymptote. It's not going to be linear. This thing is not linear. It's like a weird double, like, angled thing. Then let's try 5x minus 3. Okay, that one, not it either, has a vertical asymptote or a very steep slant asymptote, I'm not sure. And then 5x minus 2 comes up with a straight line. So this line is the other linear factor when you divide by 5x minus 2. Clearly, the way we should solve this is by factoring. So we would make a times c is 60. We would find our factors as 60 would be 15 and 4, yeah. So we'd find minus 15 and minus 4, and then we would use the area model to come up with 5x minus 2 and the other solution. right, the table shows linear relationship between distance and feet. What is the rate of change of the distance in feet with respect to time? So this one would just be doing slope formula, doing 2 rows, and doing y minus y over x minus x. Since this is not a regression, it doesn't say about. I don't need the entire thing if I want to use linear regression because it's going to be a perfect fit anyways. So I can do y1 is approximately mx1 plus b, and we get the slope is 8. So with a slope of 8, and if you're not sure if it's a regression, just put another line. So if I do 34 and 732, it's still a perfect fit. So this one's not a regression question, but we still got our answer is the rate of change is 8. So yeah, easy. Which equation best represents the line shown on the grid? So we can just try them, like y equals 0. Looks like that. That's not it. Y, let's just change that to -6. Hey, that looks right. X equals 0. Nope, that's vertical. And x equals -6, also vertical, not the one. So we can just type those in directly and see which one matches the picture. Clearly, the knowledge we should have here is that horizontal lines come in the form of y equals blank because the y value never changes. And we can see that on this graph, the y value is always -6. Number 36, an insect population can be modeled with this function. Which statement is the best interpretation of one of the values? The insect population increased by 13 each month. That's not true because it's non-linear, it's exponential. The insect population decreased by 13 each month. The insect population increased at a rate of 30% each month, decreased at a rate of 30% each month. So first thing I would do is go ahead and graph it. So we get this exponential growth curve. So we can immediately, by seeing its exponential growth, eliminate G and J. Those both say that we're decreasing, and clearly as we go to the right, the number is increasing. Then the question is it 13 every month, or is it 30% each month? So I can see that from 1 month to the next, let's go down to like where you see 1 month. So in 1 month from 0 to 1, it increased by about 13. That's about right. But then from 1 to 2, we go from 23 to 31. So that's like 18 or 17. So definitely more than 13. So if we don't know that exponential is nonlinear, then this would help us. We could go number by number and check what we get. All right. The graph of that is shown on the grid. Which ordered pair is in the solution set of y is greater than this? So we can graph that, but there's no point because it's already graphed for us. So it's an inequality, so Desmos can't really help. So all we can do is know that y greater than means the point has to be above this line. So -8, 8 is way above this line. So definitely seems like that one is in the solution set. Let's see, 6, -5, that's on the line, which means it's not greater than this. It means it's greater than or equal to. So B is no good. 4, -6, that's below the line, so no good. And -2, -7 below the line. So here's the thing, even like we did earlier with one of the problems, if you don't know how to solve this at all, just treat it like one of these things is not like the others. Like if you plot those 3 points by drawing it on your screen, here we can draw it on Desmos. So we can do y is equal to -1/6 x minus 4. And then plot these 4 points. I'm going to use a table just to do it faster. -8, 6, 4, -2, 8, -5, -6, -7. So if we just look at this picture, we have 2 dots below the line, 1 dot on the line, and 1 above the line. So like clearly it's not either of the 2 below the line because they're the same, right? They have the same condition, so they can't be the right answer. The one on the line, maybe you would pick that, but since it says greater, you should be thinking like it's to one side of the line or the other. So this negative 8/8's the only one that kind of remotely makes sense. Okay. Conversion of Celsius to Fahrenheit is linear. The graph shows the linear relationship. Okay. Which equation best represents this situation? So generally, that would be a regression problem, but we don't have a table of data. So this one, even though it says best, seems like a perfect fit scenario. So we need to know how to read this graph, or we can just kind of type them in. Y equals 5/9x. So that has a y-intercept of 0, 0. The one shown here has a y-intercept of 0, 32. So it's not that. It's also not going to be 9/5 x because that's also proportional, and we know it's not proportional. They don't have the same 0.0 Fahrenheit is different than 0 Celsius. So then I'm going to try J next because I already have 9/5 here. So that one has a y-intercept of 32, which does match that. And just for completeness sake, let's try 5/9. That has a y-intercept of 32. So it could be H or J. We need to find another point. So if we look at 5 Celsius, we're at about 40, just over 40. So let's go to 5 Celsius here is below 35, but the other one, 9/5, at 5, we are at 41 point something. So this one is definitely correct. 1 point isn't enough to define a line. We needed to find a second point to determine whether H or J was correct. All right. Okay, so we've got another inequalities graph. It looks like all of the lines are the same, so drawing this in Desmos will not help us at all. What we need to do is just know about shading and whether the line should be solid or dashed. So since these are both less thans, it means that the line itself is not a solution. So we're going to be shading, well, we should rearrange it. So this one says y is less than, and this one says y is less than. So when we rearrange it, this is going to be below both of the lines, and both of the lines will be shaded, or dotted, rather. So C is the only option with 2 dotted lines where it's shaded below both of them. Which graph represents this? Well, we can just graph it. We can even graph it in factored form. We don't even have to like multiply those together. We just graph it like that. We can zoom in here, and we've got... Let's zoom into 1. Okay, so we got the same scale going on. So this one has x-intercepts of -1 and 3, which we should know just from how factors work. So -1 and 3, we have that on F and on H. So the other thing we need to check is the vertex is at 1, -4, which matches with F. First 6 terms of a geometric sequence are shown where A1 equals -4. Based on this information, which equation can be used to find the nth term? So we have -4, -16. I would start here by creating a table because we have a list of values. So remember, in a sequence, the x's are just going to go 1 through 6. So we have 1 through 6 for x, and then our y values are the items in the series, the terms. So we have -16, -256, -1024, -4096. Okay, so we have this data, and we can try these things out and see which one fits the dots. So there's dots. We've got -4x. Remember that we're going to use x for our graphing. We have negative, and then parentheses, 4 raised to the x. We have -x squared, and we have -4 to the x. All right. So we've got... Where even is green? I don't even see green. -4 to the x. Huh. Okay, whatever. So we can see that the line does pass through this first point, but then is very wrong for the rest, so it's not black. Blue misses them all. It's pretty close at the start and gets further off the further we go. The red matches perfectly, so that one is going to be our correct answer, -4 raised to the x. I don't know why the green graph is missing. -4 to the x should like switch back and forth from negative to positive. Oh well, we won't worry too much about that. We have our correct answer is the red one, so B is correct. If we were doing it properly, we would say we're going to go backward one term, so we can see that we're multiplying by 4 at each step. So term 0, the one before -4, would have been -1, and then we're multiplying by 4 at every step. So our y-intercept is what's before the parentheses, -1, and then our multiplier, our common ratio, is what's in the parentheses. All right, what is the solution to this? So like previously, we can set this up as a system, basically. So we can do 4 times x plus 56.5. And obviously the correct solution to this is to use algebra and opposite operations, inverse operations, and move terms around until you solve it. But if we graph it as a system, we can find that these cross at 13. So the x is where they're going to be the same. Remember that my variable in these two equations is an x, so I'm looking for the x value here. The 278 is not relevant. It's the 13 that we care about. Which expression is equivalent to this one? So this is a difference of squares problem that we should factor a GCF of 4. Yeah, GCF of 4, and then we have 9m squared minus 25, which is a difference of squares. So we would get 2, and then, am I wrong? Is it not a difference of squares? 36, that's 6, 10. Oh yeah, 3m minus 5, 3m plus 5. Okay, so if we don't know that, we do 36. Since we're graphing, we change it to x, 36x squared minus 100. Let's go back home to get the right picture here. So then I can type in 9x minus 20 times 3x plus 5. That does not match. Then I can do 2 times 2x minus, I don't know why I went to the third one, times 9x plus 10. That's not correct. Let's go back to the second one. 4 times 3m minus 5, whoops, x. So notice it gave me an error, so I know to go back and make that an x, times 3x plus 5. Okay, so the red one perfectly overlaps with the green. The purple one overlapped it on one side, but the red one perfectly overlaps it. So the second one, the 4 times 3m minus 5, 3m plus 5, is the correct answer. Number 44, the table shows revenue. Exponential function can be used to model it. Which one fits best? So that should be a clue that we're doing a regression problem. And if we're not, it doesn't really matter. It'll just be a r value of 1, r squared value of 1 if it's a perfect fit. So there's no harm in doing this as a regression, even if it's not necessary. So y1 is approximately ab to the x1. Yeah, our value is not 1, so it's not a perfect fit. It looks like, it's at exponential, right? Yes. Okay, so it looks like I think in the Cambium software, this log mode button is not a thing. It's automatically checked. At least it looked like that on the interim tests. So if not, notice how these numbers don't quite match these. I need to check this log mode button to make sure it's calculating the same way as what star is doing. So we have A is 223 and B is 1.09. So that's going to match with answer F. So if that log mode button is there, you need to check it, but I don't think that it is in the actual star software. While it's the same restrictions on Desmos, that version is slightly different somehow. which best represents this set of the system of equations. So we need to, since they're not in function notation or function form, we need to rearrange them so that y is by itself. So I have 2x equals 6 minus y. So what I'm going to do is move the y to the other side by adding y, do y plus that, and then move this 2x to the other side by subtracting it, and we end up with that. And then we have 5x minus 4y equals 28. So same kind of deal. I'm going to move this 5 to the other side by subtracting 5x. And now I'm going to divide this entire side by -4 to get rid of that -4 coefficient. And again, like earlier, this is not a normal form. It's not slope-intercept or any of those, but it works. Desmos can graph it as long as the y is by itself. So our solution is going to be 4, -2, which matches with graph B. Which function is equivalent to this one? So we've done one of these already. We just do x squared plus 2x minus 15. We're intended to solve this by factoring, clearly, because these are all linear factors. But if we are struggling with that, we can just graph each of them. So x plus 15, x minus 1. That's not correct. It doesn't match the purple graph. So then I can just change this to be x plus 1, x minus 15. Does not match the green graph, rather, is the base one. X minus 3, x plus 5. Okay, that one looks like it matches. The green and purple are identical, so that's correct. Our last choice was x plus 3, x minus 5. So that one's really close, but shifted over. So that's if you factor it and forget to change the signs when you go from the factors to the solutions. That's the mistake you would make. With Desmos, it's impossible to make that mistake because we're just checking the answers. Which graph represents a quadratic function with a domain of all real numbers less than 4? So that relies on us understanding domain is less than 4, but since it's a domain, we actually, we don't have an equation, but we could graph like the parent function. So we could graph x squared with a domain limitation of x is less than 4. I guess that doesn't quite work. Oh, less than -4. So it kind of gives us the idea that there shouldn't be anything to the right of -4. I don't think Desmos is particularly helpful for this, but it is closest to matching with C because there's nothing to the right of this number. So it helps maybe a little, but not much. The graph of a line passes through these 2 points. What is the slope? Okay, obviously we use slope formula. It's 7/8. But like if we are struggling, as usual, our fallback could be the linear regression with 2 points, -3, 1, 5, 8. y1 is about mx1 plus b. So we get m is 0.875, and if we need that as a fraction, which we do, we can put m and convert to a fraction as 7/8. So G. Mail carrier delivers mail on one of 2 different routes, a morning route and an afternoon route. Each workday, the mail carrier is assigned one of the 2 routes. Last month, he delivered the morning route 16 times and the afternoon route 12 times. Okay, that sounds to me like an ordered pair, 16, 12. And so I don't know if this is useful. I'm just capturing it. This month, the mail carrier delivered mail on the morning route 10 times and the afternoon route 15 times for a total distance of 123.75. What is the distance of the morning route in miles? So this is a system of equations. And what I was trying to see is if we could use graphing to help us with this. I think I actually would approach it slightly differently. So we would make one graph. We'll do m1, x1 plus b1 because we're going to make 2 different lines. I'm not even sure this is going to help because we need to take into account the miles, the total miles. Anyways, I'm just going to try this, and if it's wrong, we'll try something else. Sometimes you got to experiment. M2 x2 plus b2. And then what we're wanting is when this one, the first one is at 141 miles. Can I change the color of these? Yeah. So when the black one is at 141 miles, we need to know when the other one is at 123.75 miles. I don't really like that. I think we're going to try a different approach and do this one more as a system. I don't think regression is the right thing to help us here. So let's write these as two equations. 16x plus 12y equals 141. And the other one is 10x plus 15y equals 123.75. So as usual, these are not in y equals form, so we're going to rearrange it a bit. We're going to subtract 16x over to this side, and then we're going to divide this entire side by 12 to get rid of this. And then we're going to subtract 15x from this side and divide this whole side by 10 to get rid of the 10. Oh, and this was y. Okay. No, I took the wrong one away, didn't I? Whoops. This was 15y. Okay, so we're going to take the 10x to the other side by doing minus 10x, and then we're going to divide this whole side by 15 to get rid of that. And see where they cross is at 5.25, 4.75. So that's telling us the morning route is 5.25 miles, and the afternoon route is 4.75 miles. So we have to be careful here because both of those are presented as answer choices. So we have to see here that it says the morning route, and note that we made the morning route x because it was the first one listed in the story. So our answer here is going to be 5.25. And of course, we could solve that as a system using elimination or substitution or graphing. Quadratic functions p and q are graphed on the grid. The graph of p was transformed to create q. So p goes up, q goes down. Which best represents the graph of q? So q is flipped upside down, but then if we look at the vertex, it's moved up 2 spaces. So notably, p is the parent function. So I'm going to write f of x equals x squared. And that's the same as the graph of p. Now, I can graph the other ones as transformations. So if I don't realize that it's a vertical reflection, meaning a negative out front, and a vertical shift of 2 up, meaning plus 2, then what I can do is put negative x minus 2 squared, and see that that is flipped upside down, but it's moved to the right instead of down, instead of up. So that's because the subtraction of minus 2 is in the parentheses. So that's not correct. The next option won't be either because this is just going to move it to the left. So then our next option is to get rid of that parentheses and do minus 2 over here. That moved down. And then our final option, plus 2, gives us the picture that we have here, so that must be correct. So negative in front is a vertical reflection, plus 2 is a shift up by 2. What is the solution to this equation? So normal deal with systems, we can put the left side, just remember to use x for our variable when we're graphing. So 40 minus 5x, and then 10x plus 5 parentheses 1 minus x. So anytime we want to find something by graphing, we need to make our variable x. And if it's if it's something equals something x, then it's y equals something x. Okay, so our intersection is at 530. Remember, x is the part we care about. Luckily, they don't give us 30 as an option, but the 5 is the x value that they share. It's where they meet, and since x is the variable we're using in the equations, x is what's important. So 5 would be the answer. It would be C. All right, the initial value of a home is $200,000. The value of the home will increase at a rate of 6% each year. So we'd have to know how to write the equation for Desmos to help us with this. So we know that 200,000 is the y-intercept, and then in parentheses is going to be 1.06 and then to the x. The problem is Desmos can't really help us with knowing that this should be 1.06 instead of 0.06 or 6. So a common error here would be to put 6 in there, but it's supposed to be 1 plus whatever the percentage is. Because it's growing by 6%. We still have the 100%, so that's like 1.00. This is 100% of the initial value, and we're gaining 6 more %. So that graph we'd have to zoom way out to see because it starts at 200,000. That's 25,000. Man, it's really, really tall. Now, the thing is, this is a case where the graph being stretched is going to be an issue. So what we can do is go to the wrench. Our y-axis, notice all of the graphs in the answer go from 0 to 900,000. 900,000. And the x's go from 0 to 30. And the y's all go from 0 to 900,000. So now this graph is going to look a lot more like what we're seeing over here because it's scaled the same. So they're hoping that if you do graph it like this, that you won't readjust the graph, and you'll see that it shoots up really, really fast. And you'll pick H because you saw it was like growing super fast. But when we stretch our graph out to match this one, we can see it's actually growing much more slowly. And we could look at a point here, say 10, like 36,000, 10, or 360,000 rather. So that's going to basically match what we see on F. So we can find points on here and match it with what's in the problem. All right, coach has 96 golf balls for the golf team. The coach will give each player on the team 8 golf balls. So this is the number of balls remaining and number of players on the team. The coach will use no more than 6 players on the team, which represents the range of the function. So this is vocabulary. We have to know that range means the y values. Desmos can't really help us here. We're just going to read them off the graph. We have 96, 80-something, 70-something, 72. So that's clearly going to be this one where we have, if we just look at the ones, actually, wait. First one is 96. Fourth one is 72. That's clearly going to be this one, not that one. So you can just look at the ones that are on nice even numbers. The first one is 96. Fourth is 72. The seventh and last one is 48. So that matches with this, option C. Next, linear function k has a 0 of -2 and a y-intercept of 6. Which graph represents it? So here we have to know that a 0 means an x-intercept. This is vocabulary again, so there's not really any way that Desmos can help you to know what a 0 is. So we need a 0 of -2. The only one that even has that is G. Then we can verify the y-intercept also is 6 on G. So if we at least know y-intercept, we can eliminate H and J immediately. And then the fact that graph F has nothing to do with -2. Oh, I guess the slope is -2. Yeah, I mean, this is a vocabulary question. Desmos can't really help with that. And I believe that's the end. So that's the end of this test, and it ends on one where Desmos can't really help us. Pretty unsatisfying. Oh well, hopefully that helps you see how you can use Desmos on some of these to help you out, and you got the idea that substituting values Systems of equations and regressions are some of the most useful things that Desmos can do for you if you forget how to solve a problem on the EoC.